Now we are preparing the solution of buffer TBE that we're gonna use in the gel. We are taking 5 milliliters of TBE and then we're gonna add water to have 100 milliliters. Practice of electrophoresis, we didn't get the results as we expected. This can be because it is our first electrophoresis and we made a lot of mistakes in the way. They could be a lot of bad pipetting, uh, some mistakes in the math, or some mistake while making the gel. I believe that the first gel with 0.6% of agarose has a lot of mistakes. We can't see the markers, we can't see a bubble in the ride, and I believe that we left it a lot of time, so that's why we can see the bands that way. In the gel that it is our third gel, that it was with 2.4% of agarose, we can see that our bands migrated a little. So I believe that in this one we could have used a little more of time, not voltage, but a little more of time would have been right. So the bands could have gone correctly. And I believe that the perfect one for this practice would have been the one with 1.2% of agarose, which is the second one, and we can see our markers correctly.
The judge should consider the following cost, budget, sites about overheating, salt content, and sample size. Because the hard time was run at 120 volts if the voltage is decreased, mobility of the bands is reduced, and the bands are winded down to its dissemination. On the other hand, when the voltage is too high decrease the resolution down overheating of the gel.
CyberSafe is less hazardous than ethidium bromide and has high level sensitivity, but it also represents other advantages, such as that it can be used with either blue light or UV light excitation. It can be used for both acrylamide and agarose gels, and it even stains RNA in gels. One of the reasons the genomic DNA shows as a single line and not bands in our gels is because it can be degraded. This means that nucleases were present. As a conclusion, it's very important to choose the agarose percentage in the gel because it will have consequences on the whole process and how the bands will migrate.
Same markers, same DNA sample, and same conditions in order to analyze the migration of the sample different percentage of agarose. At the first gel with 0.6% of agarose, we could see that the DNA migrates very fast without any defined path. It's because the percentage of agarose was not correct. This small amount of agarose allowed the sample to move more than is required. With the gel with 2.4% of agarose also was not well selected percentage because we could see that there are no defined bands and that all the DNA sample moved and created as spots. The gel with 1.2% of agarose is the one that is more accurate because it let us see the DNA separate into different bands. According to the table presented in the theoretic part of the practice, the percent of agarose is the correct one considering the size of the sample. So the better way to select the percentage of agarose needed is to know the size of the DNA sample. Considering all the information obtained during the practice, electrophoresis is a very useful technique which requires a knowledge of how to prepare the gel according to the size of your sample and how to calculate the voltage and time required to obtain the estimated result.